Hello and welcome to my session. I'm LouAnn Lovin and I'm from James Madison University. I'll be talking with you today about ways to support children in the early grades to construct number sense and fluency with number facts. So we're going to start with a brief overview. We're going to start with talking about what number sense is and why it's important for early childhood classrooms. We're also going to talk about learning progressions and what those are and how they honor children's thinking and how teachers can use them. We'll also look at some additional tools and strategies that support learning that also honors children's thinking. And then following the presentation, I will be responding to your questions in the live chat. And I wanted to also note that I've uploaded some resources in the resource room of the Summit platform. So you're probably aware of the latest NAEP results talking about the student academic achievement in mathematics and the negative impact that the pandemic has had on that achievement. We also, before the pandemic started, we're seeing the achievement gaps continuing to widen. And on top of that, we have nationwide teacher shortages. So we very likely have teachers who are in the classroom who may or may not know about the information that we know about how children learn mathematics. In the math education field, we've noted that one of the primary causes of issues with learning basic facts in math is, especially among children at risk or ones that are already experiencing learning difficulties, is that they have a lack of opportunity to develop number sense during their early school years. And so that's one of the reasons why I wanted to spend time focusing on number sense for the early grades in this session. So let's start by talking about what it means to build early number sense. We're talking about having children build and use relationships between numbers by exploring and visualizing them in different contexts and through different representations, being able to pull them apart, put them together, see numbers embedded in other numbers, and relating them in ways that are not limited by traditional algorithms or our standard procedures, which actually are digit-oriented and actually they mask the meaning of the digits involved. I cannot emphasize enough that fluency with basic number combinations and computation takes a significant amount of time to develop, and it grows out of number sense. Although you may see the basic number combinations and computations listed as items in standards of learning in second and third grade, the reality is that the ideas that actually shore those up should start in pre-K and kindergarten and continue in first grade, second grade, and third grade. Let's consider a student's response to a written assessment item, which asks the student, which of the following helps you with 12 minus 7? This particular student chose B, 2 plus 5 equals 7. And I want you to think to yourself, is this student's response correct? Is it what you expected? How would you respond if this was your student? So we're going to come back to this in a minute. But right now I want us to think about that sometimes other people see things differently than we do. So I want to ask you, do you see what I see? What do you see? Do you see a cat? Do you see a mouse? Do you see both? A lot of people can see the cat very quickly. It's the black cat with the white face. Here are the eyes, but sometimes they need help seeing the mouse. So let me help you. Does that help you see the mouse? It's the white mouse. Here's the ears, and here's the eyes. Now, some of you may still be going, oh, I don't know, I need more time to process that, and that's okay. The point is that I want everybody to think that and realize that not everyone sees what you may see. Even in math class, what do you see? Do you see the 10-to-1 relationship in these items, or do you see items to count? If you have a student that starts counting the stick on the far left, they may start counting 10, 20, 30, and then 40, which should raise a red flag. Or the student could start with the item on the left, or on the right, sorry, my other left, on the right, and start counting by ones and count 1, 2, 3, 4. That also should be cause for concern, that these students are not seeing the 10-to-1 relationship that you as an adult might be seeing. So one of the things we need to be aware of is that how someone interprets a particular mathematical idea can be very different from someone else's, the adult in the classroom, the teacher, or even another student. Think about knowing and understanding as not a have, don't have situation. Think of it more as being on a continuum where when you first start learning something, your knowledge and understanding about it is very shallow. It's not very deep. And then the more opportunities you have to interact with those ideas, then you begin to develop a more sophisticated, deeper, more complex understanding of that idea. Sometimes we as teachers, especially if we're working with students who are struggling, might feel the need or feel more comfortable simply showing students a particular strategy to use or practice. The key question I want to ask you is, well, which strategy will you demonstrate? Because too often it's the most sophisticated way of thinking about an idea, the adult's way. And the learner ends up memorizing it without understanding. I'm sure that you've seen lots of different examples of students who have tried to use the multi-digit subtraction algorithm and without understanding, they've memorized it, and there's lots of slashing of numbers and adding ones that they obviously do not understand the meanings behind. And so we want to avoid that. So let's go back to the student's problem and think about what are different ways that we could respond to the student. Possible responses: no, you should have chosen C because it's part of the fact family. Or what is 12 minus 7? How did you get your answer? Or explain how 2 plus 5 equals 7 helps you find your answer. I was actually working in the classroom where this student was, and had worked with this student quite a lot, and knew that this student knew what 12 minus 7 was. And so I was curious as to why he selected what he selected. But also, over time, this student had been told repeatedly that his mathematical reasoning was not correct because it was not the way the teacher was thinking. And so this student was beginning to develop this sense of they hated mathematics, it didn't make sense to them, and they just didn't want to do it. And so I wanted to sit down with him and figure out what was going on. So I sat down with him. So the L is me, LouAnn, and the C represents child. And so I just asked the child, what is 12 minus 7? And the child immediately said 5. And I said, well, how did you get that? And this is what he said. Well, I know 12 is 2 away from 10, so I broke 7 into 2 and 5. Then I took away 2 from both 12 and 7. So then I had a 10 and a 5, and I know what 10 minus 5 is. It's 5. And I went, whoa, that child was using some really sophisticated reasoning. But then I asked, well, why did you choose B? And the child said, because it's 2 plus 5 equals 7, and I use those numbers to find the answer. So to help you kind of track on how the student thought about this, I have used 2 different representations. So the first one is here, where the child was decomposing 12 and 7 into 10 and 2 and 5 and 2, so that then they could subtract the 2 from both the 10 or both the 12 and the 5. And they would get 10 minus 5. The child was doing this because he wanted to get it. He was using 10 as a benchmark. So he was trying to get to the 10 to figure out, to derive the number, to derive the fact of 12 minus 7. So that might help you track on it. Another way to represent it is to represent it on a number line. Oftentimes we think of 12 minus 7 as looking at the distance between the numbers on the number line. Well, the distance between 7 and 12 is 5. Well, if you shift 7 and 12 to the left, 2 numbers, you'll get 5 and 10. The distance of 5 is maintained. And so this strategy is actually called equal additions. This did not learn this strategy in this classroom. The teacher was not teaching this strategy at all. The teacher was focusing on fact families, having the students memorize the numbers that were connected, 5, 7, and 12, and then just looking for an equation that had those numbers in it. And so I also knew this child's parents, and they had not taught this child this strategy either. This child actually developed this on their own. And I would argue much more sophisticated reasoning than trying to rely on a fact family. So what are some observations about this? Well, this question was a practice item for a state assessment. It was consistent with an item on the actual state assessment test. And we might say, well, it's just a poorly written question that's intended as a summative assessment. But that begs the question, do we care how the student's finding 12 minus 7 if the student's able to do it quickly? And why would we want to force students into using a specific strategy, especially one that could be based solely on memorization and is less sophisticated than the strategy the child is using? So you may be asking, well, then how do we know which strategy or strategies to use to share with students, especially when they may be struggling? So we have a lot of research in math education that's been done over the past several decades that's actually identified learning progressions. And what those are typical learning paths that children travel along as they develop more and more sophisticated understandings of mathematical ideas or concepts. What these learning progressions can help teachers do is to make sense of our students' current reasoning. And also because we can identify where they are on the learning progression, it helps us see where do they have to go next. So it helps guide us to figure out how to help them get to that next step and develop that more complex understanding and in ways that honor children's thinking. It also dovetails very nicely with differentiating instruction because it meets them where they are. So just to share a very simple learning progression that focuses on the phases in the process of learning number facts with fluency. Now, keep in mind, oftentimes students, when like in 2nd or 3rd grade, we start going in and students are given flashcards. And so the emphasis is on memorizing the number facts. And so if we look at what this learning progression tells us, there's 3 stages or 3 phases in this process. And this was done through interviews and observations of students who the researchers were looking at it and trying to figure out what phases were they going through to actually be able to develop and know these number facts very quickly, very efficiently, and with fluency. And so the first phase is the counting strategies. And so they all start here. They're either counting all or they begin counting on. And then once they are through that particular stage, and as they're working in that stage, they begin to develop these reasoning strategies where they're using number relationships that actually work into derived facts. For example, if they're asked, what's 8 plus 3? They may say, oh, okay, very quickly in their mind, they may say, I know what 8 plus 2 is, it's 10, it's just 1 more. And so even a child that's still using a reasoning strategy like that, they may actually be able to respond very quickly. And so it doesn't matter whether or not they have it totally memorized. It's just they're able to use that reasoning strategy so quickly that it doesn't really matter that they have it memorized. Again, these students have to go through these 3 stages or these 3 phases to be able to learn the number facts with fluency. This process requires substantial instructional attention, not only several months, but often multiple years. And it starts with building number sense and number relationships early on. And what's really cool about this, knowing that they have to go through these phases to begin to really build the foundation to learn their number of facts with fluency, we know that this allows for differentiation because students can enter this process where they're currently operating. And we as teachers know, okay, well, this student's using a reasoning strategy. So what's really cool about a teacher knowing what these phases are is it allows for differentiation because we can pose tasks and children can enter this task anywhere that they're currently operating. They may be using counting strategies, they may be using reasoning strategies, or they may actually know it with automatation, I want to use that word, automaticity. And so knowing this learning progression, can help guide our instruction. Just because I've got 30 minutes, I don't have a lot of time to go into a lot of learning progressions, but I wanted to share just 3 that are connected with developing number sense. We've already talked about the first one, and there's actually references at the bottom of the slide that correlate with the learning progressions. The second one is research that was done to identify developmental stages in place value understanding. And then the third one is learning framework and number, which actually is a conglomerate of several learning progressions. And just 2 of them, stages of early arithmetic learning, which is also called SIL, and structuring numbers 1 to 20. Again, just 2 of the many learning progressions that Wright and his colleagues have developed. And we're not going to be able to address all of them in detail, but I wanted to spend just a little bit of time talking about stages of early arithmetic learning, just focusing on 3 of the 6 stages. The descriptions are provided in the resource room of the Summit platform. Again, the reference or the resource is listed there at the bottom of the slide. We're going to focus on stage 1, stage 2, and stage 3. So with stage 1, if a teacher has a student that's considered a perceptual counter, they're doing perceptual counting, this child can only count objects that they can see, that they can perceive, that they can see, touch, or hear, as in like claps. They have to count everything, so they count everything from 1. At stage 2, with the figurative counting, they no longer have to be able to perceive the objects so that they can count hidden objects, but they always count from 1. So for example, if you have a hidden collection of 5 under one mat, and then another collection of 3 under another mat, and you say, okay, there's 5 under this mat, 3 under this mat, they're going to start with one of them and actually just kind of touch the top and count by ones, 1, 2, 3, 4, 5, 6, 7, 8. And so they're not, they at this stage, they appear to have to start the count from 1 to give meaning to the total in the set. At stage 3, this is where the hallmark characteristic of they're able to count on. So they're able to do what we call view that 5 as a composite unit. They no longer have to go through the act of counting to give 5 meaning. They can actually look at it as a composite unit and operate on it as one entity. So they're able to look at that and go, oh, there's 5 there, and so they count up 6, 7, 8. So how can we use this learning progression as a teacher to help us? So if we know that we have a student that is a perceptual counter, we want to get them to be a figurative counter. Well, the difference here is the perceptual counter has to be able to perceive the objects. Figurative counter, they can count them that are hidden or screened collections. So the idea here is we want perceptual counters to be able to develop these mental images of things that they can't visually see or touch. So some of the instructional activities, these are just a few of the instructional activities. So for example, you could use domino addition cards that have flaps. And so initially, the student might want to peek and see what's under, but you can encourage them to keep the flap. They can look, but then encourage them to flap it, to close the flap, and then maybe touch the top of the flap, as they're counting it. Again, the idea is you're wanting them to develop or to begin to try to build these mental images of these amounts so that they don't have to see the physical visual object. Another idea is using finger patterns. Wright and his colleagues call it bunny ears. And so they have the student stand, or not stand, but sit or whatever, and put their hands on top of their head. And they say, okay, show me 8 fingers. And so they may, count up, with their fingers one by one. But again, the idea is they can't see them, but they, there's some kind of support that if they do need to see them, they can pull them down. But again, it's trying to get them to develop these mental images of these quantities that they're trying to count. If you have a student that's a figurative counter and you're trying to get them to the next stage, that is the counting on. And so some of the activities that we can use with them, you can use 2 different dice, one number die that just has the numerals on it, and then one that has the dots. And so have them roll the number die, and so they may roll a 3, and then the dot die, it may be a 6. And so they have to figure out, well, how are they going to handle that numeral 3? Now, initially, they may have to go, okay, that's 1, 2, 3, and then add whatever's on the dot die. But again, it's moving them away from having the actual dot array that they could count. Another idea is to use quick images, so it's very quickly shown. And so we call this subitizing quantities that are typically 4 or less. Kids can very quickly recognize that pattern, that's a 2 or that's a 3, without having to count each individual one. So again, the quick images require students to find other ways. So you quickly show it to them, take it down, and then they have to figure out another way. They have to develop this mental image in their mind, and they may still be counting them one by one, and they very likely will be at this point. But again, it's forcing them to create this, mental image that moves them in the direction of, being able to visualize that mental image, but also being able to subitize and then moving on to counting on. So I wanted to share this particular manipulative that every early childhood classroom should have in their classroom. It's a Rick and Rack, also known as an arithmetic rack. It was developed in the Netherlands. And the structure is that each row is comprised of 2 strings of 10 beads, typically 2 different colors, and it's broken up into groups of 5. And so this entices students to begin to start seeing groups of 5s and 10s. Now, with young children, you can actually have Rick and Racks that are just 1 row. So you have, 5 red and 5 white. But you can actually have 2 rows or even more rows. But typically in the earlier grades, it's either a Rick and Rack with 1 row or a Rick and Rack with 2 rows. But the idea is that the structure of the Rick and Rack offers this, the visual images for young learners to be able to see numbers within numbers and to begin to build benchmarks to 5s and 10s. So with the Rick and Rack, the young learners, even if they're still counting ones, like having to count everything from the start, so counting, the 1, 2, 3, 4, 5, 6, 7, they can still find this useful because the colors actually build this grouping to help them start looking at that as one entity. Again, beginning to work on this counting on notion. But again, it also helps them begin to decompose numbers, as in 7, the 5 and the 2. Or if you've got the Rick and Rack that's 2 rows, it's 5 on the top and 2 on the bottom. Now, sometimes students get a little confused about the beads that are on the right, and so you can either cover it up or have the students cover it up if that's too distracting. So some basic brick and rack activities, again, you can have them choose a number between 0 and 10, let's just say 6. And then before they push any beads, you tell them, I want you to think before you move the beads, how can you move those beads in only one slide or push? So again, some of the students still may be counting by ones, but they're not touching the beads. And so they're sitting there looking and counting them. And then they can take their finger and slide them all in one push. The idea is that they will eventually start seeing the 5s as a composite unit and go, that's 5 and then one more, or 5 and 2, and to be able to do that in one slide or push. Also, if you want to have them start building numbers beyond 10, you can certainly do that with the Rick and Racks that have the 2 rows. And also just having them build specific numbers. So what are the different ways that you can build a 6? 3 on top, 3 on the bottom, 4 on top, 2 on the bottom, so that they can look for different relationships about how to build specific numbers. There's also children's books or different contexts that you can use that mirror this structure of the Rick and Rack, the double-decker bus or bunk beds. And so it's, the idea is, you've got 6 kids in the bunk beds. How many different ways can you have them in the bunk beds or on the double-decker bus? These can be used with teaching in small groups. And so these pictures are actually from a first grade classroom that I was working with the classroom teacher, and the student on the left, he was a student that was counting all, and so they were working on combinations of 10. So find all the ways that you can make 10 with a Rick and Rack. And so he was, having to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The students on the right, one of the students was actually using patterns. And so what she was doing was, if she made like 8 on the top and 2 on the bottom, she quickly realized that if she slid 1 off the top, all she had to do was slide 1 on the bottom. And then she had 7 and 3. And so she was picking up on these patterns, and the student that she was working with, she was still counting all. But again, she was getting exposed to this idea of, wait a minute, maybe there's a more efficient way to do this. And then the students in the middle were using a guess and check. And so they would create like an 8 and a 2 and then write it down and then clear, push all of the beads over to the side and then just kind of randomly select, an amount and then count on, to create 10. And so we were working with them to ask them to, could they find a more systemic way or more efficient way to find different ways without clearing it and then just kind of guessing and checking. And so, but the idea behind this is that all of these kids were able to be successful entering this task because they were supported with the Rick and Rack. And then also you can use this obviously with whole class as well. But the Rick and Rack is a very powerful tool that supports students to develop a one-to-one correspondence in counting. Oftentimes when children are learning the one-to-one correspondence, if the manipulatives or the counters are loose on the table, sometimes they double count the same counter, because they are having difficulty organizing the count. Well, with the Rick and Rack, it's on a string or on a wire, and so the count is organized for them. And so it helps students develop that one-to-one counting. It also develops or reinforces the notion of cardinality. This group of 5 reds, that's 5. And so it helps develop the notion of this composite unit that they can then start operating on instead of having to count 1, 2, 3, 4, 5 to make sense of it. So it starts helping with the visualization of groupings and helps develop that counting on skill. But the big idea is that it helps to visualize and build these number relationships, by having students looking at decomposition strategies because they can see the different colors, as they combine them, how you can pull numbers apart. But the really exciting thing is that, like I've said, it allows students who are functioning at different levels to be able to be successful. So the next 2 bullets, one of them, the first one is a YouTube video that shows a teacher that demonstrates some introduction lessons using the RIC and RAC. And then the second bullet is just an activity guide that is uploaded at the resource room at the Summit platform. So the first time a first grade teacher started the year in August using quick images and arithmetic racks, this is what she said. By November, pretty quickly, by November, with a focus on reasoning and communicating their ideas about number relationships, my first graders this year are so much further ahead on knowing their basic facts than in previous years, and they seem to understand so much more. She found these and other teachers I've worked with as having this huge impact on helping students develop these number relationships and very quickly developing fluency with number facts. So yes, drill and practice worksheets and flashcards do have or can have a place in helping kids develop a quick recall of their number facts, but their place is at the very end, not at the beginning. We've got to do a lot of work helping students visualize these relationships and develop these number relationships that feed into developing fluency with number facts. And the RIC and RAC is a wonderful resource and manipulative to support that learning. So actually, and if you look at the 3 phases in the process of learning basic facts for fluency, the RIC and RAC supports students through the counting strategies, through reasoning strategies, and again, through all of those experiences, they're going to develop mastery of those basic number facts. So the takeaways from this session, fluency with basic number combinations and computation, it grows out of number sense. And it requires a lot of instructional attention over a long period of time. And so we can't wait until 2nd or 3rd grade to start thinking about having students developing these number relationships that are foundational to develop fluency with number combinations. We also need to think about how we can honor students' thinking, and we've talked about 2 ways that we can do that. The first way is being aware of learning progressions and using those to assess students and to also inform your instruction. Also, tools and strategies, the RIC and RAC. Again, if you don't have a RIC and RAC in your classroom or your teachers don't have RIC and RACs in their classrooms, in their early childhood classrooms, please get those in there. They are valuable resources for the teachers and the learners. Also, just want to remind you that the resources are available in the resource room. And now it's time for question and answer. Hello, everyone. Had to unmute myself. Thank you for joining my session. And if you have questions, you can enter them into the group chat on the right-hand side of your screen. And so we will spend some time answering anybody's questions. And I will, as we're waiting for questions to come in, I will say I do not get kickbacks on anybody buying or selling RIC and RACs. I just really am a firm believer. I've seen them really support students who were really struggling, and so I just find they're very powerful supports for student learning. So someone says, where do we find the resources for this session? I don't see them under the resources tab on their website. I will check on that. I submitted them. So I will check on that when the session's over. And if you can check back later, and hopefully they will be there, but I will make sure that those resources are available. I actually included some information on some other trajectories and other things that, other frameworks that are useful for teachers in thinking about how to create tasks and how to support students in ways that students can enter those tasks at different levels. So I will check on that. So someone says, given how helpful good math preparation is for having good number sense when starting school, why isn't more attention being paid to improving the very early math environment in the home? That's a great question. I mean, it really is a great question, because we know from the research, from just experiencing, knowing that kids that have a home environment where they're actually playing simple board games, that they are actually coming to school. They're starting pre-K, kindergarten at a very different level than children who do not have that kind of experiences at home. So that's a great question, and I think that we need to do a better job of trying to support families and support parents to know how important that is, and parents from all backgrounds. So not only schools being able to provide that kind of information, but also communities being able to do that. But yeah, it's very important. Have there been studies of the Rick and Rack? That is awesome. That's a great question. And I'll have to be honest, I don't know. I don't know that somebody has actually really studied, like done a control group that, these kids aren't allowed to use the Rick and Rack. I mean, I think that, that in my mind, that might be putting them knowingly at a disadvantage. And in research, we're not supposed to do that. But yeah, that's a great question. I don't know. I'm going to have to now go look that up. Based on, my testimony is based on my own experience and my working with lots of other teachers that have used them and have just observed the huge difference that it has made in students' learning. So I'm going to make a note. Studies of Rick and Racks. So do you have resources, ideas for parents who want to support kids at home for things like math facts? Actually, there's one of the, I'm trying to watch the time so that we've got 2 minutes left. One of the resources that hopefully, if it's not up there on the resource page, it's going to be put up there. There is some tips on helping children and supporting them to learn their basic facts, but also, you can either purchase Rick and Racks, for them to use, or you can create your own. Just get pipe cleaners and pony beads. And so you don't have to purchase a commercialized version, of a Rick and Rack. But some of the resources that I have posted, hopefully, will be very helpful for parents to use to support their children at home. So it looks like maybe the 30-second banner is coming up. So I wanted to just thank you again for coming to my session, and thank you for your questions. And I really appreciate you joining me. And if you have any questions, my email, I think, is on the resources and in the program. And so I'm happy to answer any questions that you may have after the session. Thank you for coming.